Hello students, welcome to today's lecture on artificial neural network. Today we are going to discuss about architectures of ANN that will be used in several applications. In our previous lesson, we have discussed about uh, the comparison between biological neuron and artificial neuron and how artificial neurons are inspired from biological neurons. And then we have also discussed about several types of architectures that will be used by the neurons of artificial neural networks. Okay, so today we'll begin with a simple model of artificial neural network. The model of ANN are specified by three basic entities, which are nothing but the synaptic interconnections between the neurons of neural network, the training rules or learning rules adapted for updating and adjusting the connection weights, and the third entity is activation functions. We have already discussed about activation functions in our previous classes, and these training rules and learning rules will be discussed in the next class. Today, we will discuss about how the neurons of a neural network will be interconnected together, the possible ways of interconnecting them. We'll see it today. So, network architecture means that the arrangement of neurons to form layers and connection patterns formed within and between layers is called network architecture. So today we will be discussing about this topic, network architecture. The first thing we need to understand is what is a network architecture. This is the definition. Arrangement of neurons to form layers. So neurons will be grouped together to form layers, and then neurons from one layer to another layer and also the neurons within the layer are interconnected together. So the way we connect the neurons within the layers and between the layers are called as network architecture. Okay, so that is the meaning of network architecture. And based on how we connect the neurons together within the layers and between the layers, there are five basic types of neuron connection architectures. The first one is single layer feed forward network. Second one is multi-layer feed forward network. These two come under feed forward networks. Then single node with its own feedback is the third category. Single layer recurrent neural networks and multi-layer recurrent neural networks. These three comes under feedback networks. Okay, so we'll see how the connections will be made in all of these types of neural networks. The first category is single layer feed forward neural network, in which there will be only one input layer and one output layer. See, this is input layer where x1, x2, so on, xn are the neurons, and the output layer contains y1, y2, so on, yn. These are all the neurons, and the neurons are connected as uh, x1 is connected to y1 with a weight w11, x1 is connected to y2 with a weight w12, and so on. X1 is connected to the neuron yn with a weight w1n. Similarly, x2 is also connected with all the neurons of output layer with these connections, and so on. Xn is also connected with all the neurons of output layer. Okay, so what we need to understand is the connections are forward connections from input layer to output layer. Input layer acts as a buffer just to forward the corresponding inputs from this neuron to the next neuron. There will be no processing happens in input layer. Output layer neurons will perform some processing by receiving these weights as inputs and then produces an output over here. Okay, so all the processing happens at output layer only. Input layer neurons will not perform any processing. They will simply forward the input to the neurons of next layer. So this is called a single layer feed forward neural network. So that's what I explained. Layers are formed by taking processing elements and combining them together with the other processing elements. When a layer is identified, the inputs can be connected to the nodes of next layer with various weights, resulting in a series of outputs, one per node. Okay, that's what it is shown here, right? These neurons are grouped together to form the input layer, and these neurons are grouped together to form output layer, and these are connected with some weights. The second category is multi-layer feed-forward neural network. Uh, the difference between single-layer feed-forward network and multi-layer feed-forward network lies over here. You can observe the difference. There lies some hidden layers, extra hidden layers between the input layer and output layer. Except this difference, other things are going to be same as the single-layer feed-forward neural network. The connections are again from one layer to the next layer, next immediate layer. That means input layer neurons are connected to the first hidden layer with the help of weights, and first hidden layer neurons connects to the second hidden layer neurons with the help of weights, and finally second hidden layer neurons are connected to the output layer neurons. Again, X1, X2, so on, Xn are input layer neurons where they act as simply the buffering neurons, and processing happens at hidden layers and output layers. Okay, right. So this is the explanation given. A multi-layer feed-forward network is formed by the interconnection of several layers, wherein single layer feed-forward network contains only input layer and output layer. There will be no hidden layers at all. Whereas in multi-layer feed-forward networks, there exists some hidden layer. Number of hidden layers depends on the corresponding application that we are using. So it will be decided by the corresponding designer. The input layer receives the input and has no function except buffering the input signal and forwarding it to the hidden layer. Output layer generates the output of the network. Okay, and other layers that are formed between input layer and output layer are called hidden layers. So remember this: input layer, output layer, and hidden layers. These are the layers used by multi-layer feed-forward networks. And all the connections are forwarded again. Every neuron of one layer connects with every neuron of next immediate layer. The third category of neural network architecture is single node with its own feedback. Observe this. This is a neuron where all the inputs are given, and this is the output from neuron, which will be forwarded to the neurons of other layer. Now, if you observe, there is a feedback connection connected to the same neuron. That means output of the neuron is connected back to the same neuron. So this kind of neurons are called as feedback neurons, and we can make use of these feedback neurons to form a neural network also. This is a simple example for MaxNet, where all the weights are given as minus infinity, and all the neurons are built as feedback neurons. You can observe this as output of each neuron is connected back to the same neuron. Okay, this is one possible way of building the max nets or competitive interconnection net. Okay, the next category of neural network architectures is single layer recurrent neural network, where we make use of feedback neurons only. If you observe this, the output of y1 is connected back to y1, y2, and so on up to yn. That means output of a particular neuron in a particular layer is connected back to all neurons of the same layer. We'll see what will be the benefit we are going to get if we connect the feedbacks back to the same neurons later in our fourth unit. Okay, so as of now, just understand the architecture, the difference between feed-forward networks and these recurrent networks. Recurrent networks are called as feedback networks. The reason is the output of neuron is connected back to the neurons of same layer. Okay, this is how. Similarly, output of Y2 is connected to Y1, Y2, and so on Yn. So because the outputs of neurons are connected back to all the neurons of the same layer, these are called as single layer recurrent neural network. Okay. So there exists only one input layer and one output layer here. Output neurons are connected as feedback neurons. Then multi-layer recurrent neural network contains hidden layers, extra hidden layers in between input layers and output layers. And the output of Y1 is connected back to the uh, hidden layer neurons. Observe this. Not to Y1 or Y2 or Y1, Yn. The output of Y1 is connected back to Z1, Z2, and so on Zn. So, if you have a multi-layer recurrent neural network, then the output layer neurons are connected back to the hidden layer neurons. That's what you need to understand. Okay. So the processing elements can be directed to the processing element in the same layer and in the preceding layer, forming a multi-layer recurrent neural network. That is what the concept is. Previous layer neurons are fed back with the output of next layer. That is the concept in multi-layer recurrent neural network. They'll perform the same task for every element of a sequence, with the output being dependent on the previous computations and also current computations. That is the concept. So it will take the previous inputs as well as the processed inputs also. The present output is considered as the new input along with the previous inputs for the neurons. Okay. So the main feature of recurrent neural network is its hidden state, which captures some information about the sequence of processing. Right. So this is about multi-layer recurrent neural network. The main concept is output of the output layer neurons are fed back to the neurons of hidden layer. The next category is radial basis function neural network. This is same as a feed-forward neural network, except that a special activation function is used. Special activation functions are used with this radial basis function neural network. Except that difference, um, everything else is going to be same as multi-layer feed-forward neural networks. So generally, in multi-layer feed-forward neural networks, we'll make use of sigmoid or logistic functions. Instead of that sigmoid or logistic function, we'll make use of some kernel functions to design this radial basis function neural network. Okay, so we have this radial basis function neural network in our syllabus in fourth unit. The entire unit is about this radial basis function neural network only. We will learn more about this RBFN network in fourth unit. Okay. And another important category of neural networks is convolutional neural network, where a special convolutions are used in place of general matrix multiplication in at least one of the layers. Okay. So these are the special neural networks that makes use of convolutions in place of general matrix multiplications to find the output of the neural network. So we don't have this convolution neural networks in our syllabus. So just understand that there exists convolutional neural networks. If anybody is interested, you can go through the convolution. You can learn them because they are essential in designing applications of image processing. Okay, and this is a general topic. The important type of neural networks that are useful in designing machine learning applications. Solutions for machine learning applications can be designed with the help of these famous neural networks. The first category is modular neural networks. The second one is feed-forward neural networks. The third one is radial basis function neural networks. Fourth one is coherent self-organizing neural network. Fifth one is recurrent neural network. Sixth one is convolutional neural network. And the seventh one is long short-term memory, or in short, it is called as LSTM neural networks. Okay, out of these important neural networks, we have modular neural networks. We don't have it in our syllabus. Second category, feed-forward neural network is available in our syllabus. We'll learn this design of feed-forward neural network in third unit. Radial basis function neural networks are also there in our syllabus. We'll learn about these radial basis function neural networks in our fourth unit. We don't have this coherent self-organizing neural network in our syllabus. Recurrent neural networks are also not available in our syllabus. Convolutional neural network not there in syllabus. Long short-term memory is not there in our syllabus. So we have only these two feed-forward neural networks and the radial basis function neural networks in our syllabus. We will learn them in the third and fourth unit respectively. Okay. And this is the summary of all the types of neural network architectures, which is our topic of today for discussion. The neural networks are basically divided into two categories based on the interconnections made. One is feed-forward neural networks, and the other one is feedback networks or recurrent networks. Under feed-forward neural networks, there is single-layer perceptron, which contains one layer only, and the feed-forward networks are divided into multi-layer perceptrons also, where multiple layers are available. So here single layer means single output layer and single input layer. Multi-layer perceptron means there will be one input layer, one output layer, and you will be having some hidden layers also in between. And the radial basis function neural networks are also feed-forward networks. They are also same as multi-layer feed-forward networks, except that a special kind of activation function will be used for designing. Okay, we have only these in our syllabus. These three we will discuss about feed-forward networks only in our syllabus. Okay, and then the second category of neural networks is feedback networks or recurrent neural networks, under which we have competitive networks, Cohonan's SOM, half-field network, ART models. We don't have all of them in our syllabus. Okay. Anyhow, competitive learning is present in our syllabus in second unit. During that phase, I will explain about competitive networks also. Okay, except this, other things are not available in our syllabus, right? So this is the summary of neural networks that we discussed till now. Okay, so based on the application that we are considering for designing neural network, we can decide on which neural network architecture will be suitable for solving that corresponding application and make a decision about the neural network architecture to be followed for designing the solution for the corresponding application. Okay, so this is about the neural network architectures. That's all for today's lesson. Um, so the first unit syllabus, as I explained in our earlier lessons, it contains only few topics. The first lesson is about comparison between biological neurons and artificial neurons, which I explained in our classroom session. And then the second class, we have discussed about activation functions. And today we have discussed about the possible models of artificial neural networks. Uh, Anyhow, most of the students were absent for the classroom session. So in our next class, I'll make a video about explaining that biological neuron, the structure of biological neuron, and the structure of artificial neuron, and a simple model of artificial neural network also. Okay, so that's all for today. Thank you everyone for your patient listening.